Hello, Chem students. This is yours truly, Professor Ship, and I wanted to provide you guys with a great video today based on moles, atoms, grams, how to do those calculations. And so for those of you that are probably wondering, okay, so like, what is all this about? I am going to explain how all of this works. So here's the thing that you have to remember. When you're doing these types of calculations, you need two things. You need your periodic table and your calculator because you're going to be doing calculations for these kinds of problems, okay? So you need your periodic table and your calculator. Now, one thing you need to keep in mind is that depending on the type of periodic table that you use, you may find that using the significant digits will vary from periodic table to periodic table. So my recommendation is that you go with one that has smaller number amounts, okay? But the one that I am using is based upon the calculations that I have already. So, are you ready? I'm ready. Let's get into it. So, on your screen right here, you'll see that there are some basic foundations of what you need to know for calculating what's called the mole concept. And when it comes to counting atoms, you got to keep in mind that you're going to look at your compound. And those elements within your compound will let you know how many atoms you have of each element by looking at the subscripts. Remember, your subscripts are down below, okay? So let's go ahead and get into a couple of these examples. We won't do them all. We're going to do some of them because I'm trying to keep this video very short and to the point, okay? So I'll do like at least half of these problems. So let's go ahead and do the first one. If you look at the first problem, you have calcium oxide. If you look at the subscripts, which aren't any present, you know that means you have one calcium and one oxygen. That's simple, okay? That's simple. Let's look at number two. If you look at the subscript of sodium, you have a 2. And if you look at the subscript of sulfur, you have 1. Okay, let's skip on down to number 4. You have cobalt and you have oxygen. How many cobalts do you see? And if you said 2, you are correct. How many oxygens do you see? And if you said 3, you're also correct. Okay, so let's keep going. Let's keep going. Let's get number 6. I've got K2SO4. I've got 2 potassiums, 1 sulfur, and 4 oxygens. So you see how easy this is? All you're doing, guys and gents and ladies, you're using the subscripts. Now, here's another little catch though. When you get to problems like number 9 and number 10, you're going to still use those subscripts, but you also need to be aware of what's on the outside of those parentheses. So if you see parentheses present, you're going to do what? Use them and multiply them. So let's look at magnesium for number 9. You've got 1 magnesium, but when you look at your nitrate, let me go ahead and zoom in to show you what you're going to do with this part, okay? So for number 9, when you look at your formula like this, you have NO3, and on the outside is a 2. Okay, so let's get back to that part. You have that subscript of 2 that I was trying to say earlier. Okay, now what you're going to do is you're going to look at the fact that you have a nitrogen and an oxygen. That 2 on the outside means you're going to say 2 times the subscript of whatever is attached to the elements. So even though there is an imaginary 1 there, we're going to just safely say that that's a 2, okay, in terms of saying 1 times 2, okay? Remember, if you don't see a subscript like this, okay, if you don't see a subscript on the end, that just simply means 1, okay? But because of that parentheses, you're going to say 2 times every subscript inside that parentheses. So for oxygen, you have 3 times 2 to give you 6. So when we go back up here to our number 9 problem, we're going to put that we have 2 nitrogens and 6 oxygens. Okay, you got that? All right, good. Now let's go ahead and look at the next problem. Number 10. Number 10 says aluminum sulfite, okay? So what you're going to do, once again, separate everything out. You've got aluminum, which you see there are 2 of them. So I'm going to put the 2 there on that line. And for sulfur, you have 3 of them, because remember, there's 1 imaginary, and the number 1 right there beside sulfur, imaginary. And so therefore 1 times 3 is 3. And then for your oxygen, you have 3 times 3 to give you your 9. Okay, so you have 3 sulfurs and 9 oxygens. That's it. Now, the reason why we're doing this is because when we get into the next part of our calculations, you're going to have to calculate what's called the molar mass. Now, the molar mass simply means take the subscripts of each of those elements and multiply them by their molecular weight from your periodic table. So let me zoom in and give you a copy of the periodic table so you can see where we're getting these numbers from, okay? Hold tight. All right, so here's the copy of the periodic table, and I'm going to zoom in so you all can see it. But if we were looking for calcium, okay, calcium is right here in group 2. So what you're going to do is simply use the information that you have from before, okay? So here's calcium right here. And if you look at the weight, 40.078, you're going to use that for this fill in the blank part, okay? So I'm going to go down here, back to my worksheet, and we're going to fill that in. So I'm going to put that I have 1, okay, calcium times 40.078. And by the way, when we talk about units for molar mass calculations, the units are grams per mole. In other words, for every gram of a certain element is equal to that mole of that particular element, okay? So think of it this way. If I'm driving on the highway 65 miles, okay, per hour, I don't have to say per 1 hour. The 1 is understood. So just as I'm saying I have 40.078 grams per 1 mole, it's the same thing in chemistry, okay? That's just a little FYI, okay? So going back to our problem, again, if we look at our periodic table for calcium, it was 40.078. Those were the molar mass, or the weight of calcium. Now, the other element that we need to look for is oxygen, okay? So for oxygen, on our periodic table, they're giving you 15.999, okay? So to make it a little easier, let's just go ahead and round it off to 16.00, okay? That's just going to make life a little simpler when it comes to these calculations. So again, in our formula of calcium oxide, we had 1 calcium atom, and we have 1 oxygen atom. Now what you're going to do down below in this space, you're going to write what that equals to right there. And then you're going to add these 2 numbers together. So you've got 40.078 grams per mole plus 16.00 grams per mole. And I get 56.078 grams per mole as my answer, okay? Now, because we're going to go by a significant digits rule, it says you should have the least amount of digits after your decimal place. So therefore, this answer here is going to become 56.08 grams per mole. Okay? Now, I know you're probably saying, oh, why do we have to go and do all these significant digits? Well, depending on those of you whose teachers are given homework and you are using the homework calculations based on significant digits, it's very important that you follow those rules or your answers will come out wrong. That is why we're making sure that you keep that in mind. Okay? Now let's go ahead and get back into these problems. So now for number 2, you've got sodium sulfide, Na2S. So again, if I go to my periodic table, I'm going to find that sodium has a certain weight, just like sulfur has a different weight. So I have 2 sodiums here, okay, but let's change that color up a little bit so we can have a different look on these problems. All right, so let's go with green. Okay, so we've got 2 sodiums here times the molecular weight from the periodic table, and we're going to grab that in a minute. We've got 1 sulfur atom times this molecular weight. So let's go up to our periodic table here, and let's find sodium, and let's find sulfur. All right, so here's sodium over here. It is in red, okay? Over here in group 1, the weight here is 22.990. So we're going to scroll back down and put that weight here, 22.990 grams per mole, okay? Because of space, I did not write that in, as you can see in the examples, but my final answer has that unit there. Just keep that in mind, okay? Now let's go ahead and get into sulfur now. Sulfur has a molecular weight of 32.066 right here, okay? So we're going to write that number down, 32.066. So right here, we're going to go ahead and write down our calculations. So go ahead and use your handy dandy calculator for this part, okay? So what we've got here, 2 times 22.990 gives us 45.98, okay, plus 32.066. Now when I add those two together, I get 78.046. But again, ladies and gentlemen, we're going to go by the least amount of significant digits. Therefore, the least amount tells me that I'm going to have only 2 numbers after my decimal. And it becomes 78.05 grams per mole. Okay? So these are quite simple. Again, all you're doing here is calculating the molecular weight of these compounds. Now, the reason why you're having to do that is because when we get into calculations, conversions, when we have to convert a mole to a gram to a mole to an atom, these numbers are going to play a major role in making sure that you can do that. So let's go ahead and do an example like that now, okay? So again, these problems repeat themselves over and over and over. Now, if you're in my class, the answer key to all of these problems are on Blackboard. Those of you that are not my students, but you find this information valuable, I appreciate you. But all these answers here, I'm not going to place here. I'll just do a couple. That way you can check yourself, okay? How about that? So I'm going to just do one more example, okay? And we'll do magnesium nitrate, okay, right here. MgNO3 with the 2 on the outside. So we've got 1 magnesium times its weight. We've got 2 nitrogens times its weight. And then we have 6 oxygens times that weight, okay? So I'm going to go ahead and pull this back up. You know what? I'm going to pause for a minute. I'm actually going to bring the answer key here right now. Bling! So you can see these answers. And what you can do is pause the screen, pause your video so you can look at the answer key. I don't know why I didn't think about that at first, but that's what you can do. So rather than me writing all of these down, I'm going to actually give you some practice problems. And I'm just going to place the answers on the screen right now. Okay, let's pause for a minute. All right, let's get back into these problems now. Now, again, based on what you know, you're going to have to use the calculated molar mass of each of those elements and compounds to now do this part. So I'm going to give you all 4 simple formulas that you need to know. If you are given moles, and I say, hey, let's convert that to a gram. The reason why we're having to do this is because in chemistry, if you're working in a laboratory setting and you're dealing with small numbers or even large numbers, and you're doing some type of reactions and you're having to do some conversions with balancing equations, that's where this part comes into place. Those of you guys who are my students who are going into the nursing program, you will not have to calculate the moles of your patient's blood work. You will not have to calculate the grams of your patient's blood work. However, the purpose in doing this is to get you in the habit of using math skills in everyday life situations. So let's go ahead and show you all how to do this first type of calculation. I'm going to give you 4 formulas. If you are given moles and they want the answer in grams, you're going to do the following. To go from a mole, and the unit for moles is MOL, so they're abbreviated. So to go from a mole to a gram, and the abbreviation for gram is G, you're going to multiply by the molar mass. The molar mass is what we just got through solving above, okay? You're going to multiply by the molar mass, and I'll show you those examples shortly. For part B, if you are given grams and I want the answer in moles, well, what's the opposite of multiplying? You're going to divide, okay, by the molar mass. So I am going to do a couple of examples like that so you can understand, okay, how to do them. And I'll come back to letter C and letter D because I want you all to first understand how to do just those first steps before we move on. So for this particular problem on the screen, it says calculate the moles for each of the following. So in other words, I'm going to convert 12.5 grams of calcium to a mole, okay? To a mole. Of calcium. So what you're going to have to do is that anytime, and this is an FYI, anytime you have an element, okay, this is something that you all need to know right here. Anytime that you have an element, okay, FYI, elements are one-step problems, okay? And what do I mean by one step? You only simply have to take 12.5 grams of calcium, and on the top you're going to put 1 mole of calcium, and on the very bottom that molecular weight of calcium, okay? This is one step because it's an element. Now what I'm going to do is cancel out my like terms, grams and grams. They're going to slash away, but what's going to remain on top is what you're trying to get to, which are your moles. So I'm going to take that 12.5 and I'm going to actually divide that by 40.08. Now, technically speaking, you can say 12.5 times 1, but you know 1 times anything is still whatever that number is. So 12.5 divided by 40.08 gives us 0.312, okay? 0.312 moles of calcium. Now, watch what happens, and this is it. Okay, we're done. Now, watch what happens when we take 4.7 grams of calcium hydroxide and convert that to a mole. Now, remember when I said earlier, when you have an element, it's one step? Well, that element was calcium. It was by itself. It was solo. But now in this case here for calcium hydroxide, that is a compound. And so whenever you're trying to calculate the mass or the moles for compounds, that is a two-step process. So step 1, you're going to calculate the molar mass, okay, of your compound, okay? That's what you're going to do. You're going to calculate the molar mass of your compound. So, and how do we do that? It's like what we did before. We're going to separate each of our elements out, okay, to get our answer. You've got 1 calcium, 2 oxygens, 2 hydrogens, and you're going to multiply each of those by their weights, okay? So again, to expedite this, I already know what those numbers are, and I'm just going to put them here on the screen, okay? So 1 times 40.08 is 40.08. 2 times 16.00 is 32.00. And 2 times that 1.01 is 2.02. You're going to add those numbers up okay? And you're going to get 74.10, okay, grams per mole. That is your molar mass. That's step 1. Now, step 2 says, take that number, the 4.7, and divide that by that 74.10, okay? So let me go ahead and show you. Okay. Step 2, you're going to take that 4.7 grams of calcium hydroxide, and you're going to say times, and on the very top, because you're trying to get to the mole, you're going to put 1 mole of calcium hydroxide on the very top, and on the very bottom, that number that you just calculated, okay, 74.10 grams of calcium hydroxide. And you know what's going to cancel out? Grams of that, okay? Those units, because they are the same, they're going to cancel themselves out. So now what you're going to do is simply divide. So punch in that number, 4.7 times 1 is 4.7, and then divide that by 74.10, and you get 0.063. Okay? And you need 2 significant digits in your final answer. Moles of calcium hydroxide. And that's it. So I've just worked out 2 problems. Okay? And now I'm going to do another set. And again, what I want you to do is pause the video. Go back through it again if you see something that you're like, wait a minute, what did she just do? Okay? Go back through it again. Now, let's look at the next type of problem. Here in this particular example, they want you to calculate the grams for each of the following moles. So you're going to have to go from a mole to a gram. So that means you're going to be multiplying each of these numbers by their weights, okay? Remember how I said earlier, if you have a compound, it's 2 steps, and if you have an element, that's 1 step? Well, guess what? This is a 2-step problem. Why? Because H2O is a compound. So step 1, I am going to calculate the molar mass for H2O. Now I've already gotten that answer, so I'm just going to go ahead and put it on the board or on the screen so you all can see that. 18.02 grams per mole. Remember, you have your 2 hydrogens times the weight, and you have your 1 oxygen times its weight, and you get 18.02. Now, the easiest thing is you can also Google the molar mass of these problems, okay, to save you some time. However, if your teacher doesn't allow you to do that, hey, you already know how to do it the old school way, okay? So, you're going to take in step 2 the 5.57 moles of water times. Now, on the very top, you're seeking out those grams. So I'm going to put 18 grams on the top this time. Remember on the previous problem, the grams were on the very bottom? Well, in this particular case, and let me scroll up so you can see it, okay? Remember how the 18 grams, the grams of any problem was on the very bottom? Well, now in this case, it's going to be on the very top because that is the unit you're trying to get to, okay? So now what you're going to do on the very bottom is you're going to put 1 mole of H2O. And the moles are going to cancel out. So now all you're going to do is multiply those 2 numbers. 5.57 times 18.02. And what do you get? 100 in the decimal there. It says 100.3, but remember, when you're multiplying numbers or dividing, you go with the least amount of those numbers within significant digits. So therefore, because 5.57 has 3 significant digits, my 100 with the decimal on the end has 3 significant digits, and that's grams of H2O, okay? Let's do the last one. You've got 0.890 moles of neon. This is an element, so what does that mean? One step problem. So the only thing you would need to do at this time is just look up the weight for neon, okay? Remember, on the very bottom, 1 mole of neon, and on the very top, you're going to put the molar mass of neon, okay? So whatever the weight is. And the molar mass is 20.18 grams. Now again, let's go back to what we know is going to cancel out, the moles and the moles, okay? And when you multiply those two numbers, you get, and remember, you need to have 3 significant digits as your final answer. I get 17. Let me show you, 17.96. But remember, you only need 3 of those digits. So therefore, it's rounded up to 18.0 grams of neon. That's it. In the next video, we're going to show you all how to do atom calculations when you're going from an atom to a mole to an atom. So we're going to keep this video short and to the point, and part 2 will be atoms to moles, moles to atoms. And I'm going to give you all those 2 formulas for those. If you have any questions or concerns about these types of calculations, make sure you look at some of the other videos that I have, or put your comments in the comment section below, and I'll be sure to get back with you with a response. Have a great one. Bye.